Hello, I'm going to walk you through a multi-agent system I actually run, doing real engineering work that ends in code, tests, and a commit. No diagrams with nothing behind them. By the end of this recording, you'll have watched a feature get built, validated, and shipped through the pipeline, and I'll see the traces. So here's the map for the next 15 minutes. Architecture and why this shape, context management, what each agent actually sees, a live demo, then the section I care most about, validation, and how the system can just make things up. After that, where the human sits, what happens when an agent returns garbage mid-pipeline, how the system improves week over week, and finally what it costs to run and how I would know it's degrading before the output turns wrong. Let's start with the shape. This is OpenCode running 85 named subagents, each defined in a markdown file with pinned model and temperature. The routing between them lives in a plain markdown file agents.md as a decision table, not in code, not in a graph. Delegation depth is set to 5, so an orchestrator can recursively fan out to specialists. And there's a tool plane of 14 MCP servers such as Context 7 for docs, Git, SQLite, and so on. The flow you will watch today, a human prompt goes to agent organizer, which decomposes the task and delegates to backend developer and test writer. The work lands on disk, a test suite runs as the gate, and only then does a human approve the commit. Every hop in that chain starts with a fresh context. Why this shape? 3 reasons. Composition over configuration. The router is editable prose, not a schema or a state machine. Second, each agent is model pinned at low temperature, so a role behaves predictably. Third, fresh context per hop means long runs never suffer the context bloat you get when one giant agent carries everything. We didn't start here, we compared and rejected 3 other shapes. This table is the honest version of that comparison. LangGraph or CrewAI give you a graph state machine that buys you explicit state, but it costs you graph rigidity. Adding an agent means editing the graph and redeploying it. For routing that we change every week, that's the wrong trade. Cursor is an IDE chat with a rules file. It has no real subagent orchestration. It's a single context doing everything, which is exactly the bloat problem we are trying to avoid. Cloud Code is the closest competitor. It has subagents and permissions, but our agents leave us flat markdown files that a router can invoke by name. And the granularity is the whole point. So, rejected a single mega agent, rejected the graph frameworks, rejected a routerless swarm. Quick proof this isn't just a claim. Here's the config, subagent dev5, compaction on. And here's the agent's directory, 85 files. Adding a specialist is creating one markdown file. Changing routing is editing one table. That's a deliberate trade. We trade graph formalism for a system we can evolve in a text editor. Context management is where multi-agent systems die, so let's be concrete about what each agent sees and doesn't see. Each agent's entire visible universe is its front matter model, temperature, mode, permissions, plus the task message it was handed. There is deliberately no cross-agent memory. State moves between agents through the test contract. The orchestrator's message is the state object. 2 specific patterns for the failure modes you ask about. Context bloat on long runs, compaction with after and prun summarizes the conversation before it grows unbounded. And because each hop is fresh, we only ever compact with one hop, not the whole pipeline. And the stale context, we never trust memory for anything that matters. If an agent needs a fact, it rereads the file. Ground truth is the repo and the test output, never the conversation. Now the part that has to end in code. The repo is toystats, a Node CLI that computes mean, median, and mode with the committed green baseline and 12 passing tests. The task is to add a percentile flag and a table output with tests I'm going to dispatch this through the real pipeline, the agent organizer, the specialist, the test gate, and we will not stop until the suit is green and commit exists. This is the section you said you wait most. How do we know the agent isn't making things up? Answer: we don't ask the LLM to check the LLM. Every claim that matters is asserted mechanically, vitest with exact numeric expectations, linked and billed as separate gates. Grounding works because outputs are only ever checked against known inputs in code by a test runner. And I want to show you a real failure we caught and one we missed. The one we called the spec days percentile uses linear interpolation. The first implementation shipped nearest rank. For the array 1, 2, 3, 4, at the fifth percentile, the agent returned 2. The spec says 2.5. The test failed, the gate blocked it, and the fix was forced before anything landed. The one we missed, our first test set only covered sorted input. The unsorted case, 4132, returned 2 instead of 2.5, and it chipped. We caught it because a reviewer at the edge test. It failed and now the implementation sorts internally. That failure became a permanent regression test. This is the loop: write the test, watch it fail, fix, watch it pass. That's the whole anti-hallucination story. Where does the human sit? At the boundaries that matter. The human reviews the diff, the code, not the agent's explanation of the code. The human is the decision gate at permission boundaries. Bash actions and file edits are asked by default, so nothing side effectful happens silently. And the human decides scope and merge. The split is the agent decides mechanics, the human decides intent. Nothing deploys, nothing merges without an explicit human decision. That's a hard rule, not a preference. What happens when subagent 305 returns garbage? First, the gate fails before the garbage reaches anything that matters. This pipeline has no path for an unchecked agent output. Second, retry with the failure as input. The failed test becomes the new test contract, so the retry is grounded, not a blind do-over. Third, fallback. If the specialist keeps failing, we route to a different one, and if that fails, the human takes over. Fourth, rollback. Because the baseline is committed before the test starts, rerunning the pipeline always starts from the same green commit. Idempotency comes from that. State is git plus test output, never agent memory. If you kill the run mid-task and restart, you restart from the commit, not from whatever the last agent claimed. How does the system get better week over week? Three channels. First, every failure we catch becomes a regression test. The suit grows in lockstep with the failure history. Second, recurring failures become rules in agents.md. For example, always store before computing a percentile. The router itself is the prompt improvement surface, and editing it is a text edit. Third, the vitest suite is the evil harness. Rerunning the full suite is the regression check. Green is the contract, and if a change to the router or a prompt breaks it, we know before users do. Cost and latency first. Token cost is tracked per run in the session database. There is a /cost command. Latency is time from task dispatch to green gate for this size of task, minutes. But the metric that tells me the system is degrading before users notice is the retry rate. If Subagents start returning garbage more often, the test gate catches it, so output stayed correct longer. But the retry and failure rate rises first. That and the failing test pass rate are the leading indicators. By the time a user sees a wrong answer, the system has been complaining for a while in the traces. To sum up, you have the repo, the feature landed with tests and the commit, real work and real end state. You have the traces from this run, plus real tool output logs from the system's history. And you have the architecture story, 85 subagents, a markdown router, mechanical validation, a human at the decision gates, and the leading indicator for drift. The honest summary is this: the system doesn't work because the agents are smart, it works because the pipeline treats every agent output as an unverified claim and verifies it with the test runner. That's the difference between a multi-agent system and a chat with extra steps. Thank you.